Right, so here we have the sample that's been baking for 2 hours at 60 degrees C. So that's now set, so we can see the PDMS is nice and solid inside the petri dish. So we're going to leave that here for now, and we're going to prepare the punching. So for the punching, there are generally two options in this lab. One is to use a manual punch that looks a bit like this one, where you have a tube which is sharpened to a cutting edge at the very top, and then you can use this to put your piece of PDMS on the table or on a cutting mat, and then you punch manually through the PDMS. And then it also has this plunger that allows you to push out a piece of PDMS if it gets stuck inside the puncher itself. So this is a manual option. It's a sort of a semi-disposable tool, so you can use it for until it gets blunt, essentially. Once you notice that it doesn't cut very well anymore, you can just throw it away and use a new one. So today we're going to instead use this punching machine here, which is, again, it's a manual punch, but it's lever operated. So we're going to hold the punch, a cutting tube inside this chuck, and then we're going to operate it with a lever, and this guarantees that the cut is straight. So the inserts for this machine are in this box, and specifically the one that we will be using today is the one with a cutting diameter of 0.74 millimeters. So of course refer to the notes of the course to know what kind of diameter you should be punching for the type of object that you want to insert into the PDMS. So specifically for this 0.74 millimeters punch, we're gonna then afterwards I'm planning to insert tubing which is about 1 millimeter in diameter, 1.1. So you always want to make a hole that is maybe 20 to 30% smaller than the object you're trying to put into the hole. And this guarantees that because the PDMS is quite compliant, it will sort of wrap around the thing that you stick into the PDMS, whether it's a piece of tubing or a metallic fitting, and this will guarantee a leak-free connection. So I'm going to take out the insert. So that is a cutting insert. So this is a new one, sort of one that is that works, that it's as it should be. So here you can see that we have one side that is coated, and it has this yellow coating. It's a titanium nitrate coating that is designed to make it a little bit more robust, a little bit more hard wearing in the use. So one of the two sides, for specifically the one that is coated, is sharpened to a cutting edge. So this side of the tube is sharpened to and tapered, and that's the side that does the cutting. So you can then pick up this cutting tube, and you can place it inside the chuck. And here you have to be a little bit gentle. So you want to insert it by maybe 10 to 15 millimeters. It doesn't need to go in very far. And then you gently want to rotate the chuck itself, the self-tightening chuck, and then you want to make, I'm going to insert it maybe a little bit more. And then before you tighten it a little bit more strongly, you have to check that it's actually on the axis of the chuck itself. It's very easy because the tube is very thin when the chuck is undone to put it in at an angle, but tightening it while it's at an angle, you risk that the jaws will crush the cutting tube. Also, it will either split or it will get damaged. So make sure that before you tighten it, finally for the cutting step, that it's centered, so you can look at it from one side and on the other and make sure that it's on the axis. So once that is done, I will just gently tighten it a little bit more, just to make sure it doesn't slide off. And now we are ready for the cutting. So before we do the punching itself of the inlet holes, I will do the cutting of the PDMS. So for the cutting of the PDMS, I will just use a surgical blade, but any sharp knife will work well. These are particularly good because they're sharp and they're also disposable, and you can replace the blade, and there are many types of blades available. So in the cutting, you want to cut within the area of the glass. So you don't want to go down to the level of the petri dish, you want to stay within the region of the glass. You want to stay probably a few millimeters away from the glass itself, so you don't scrape the edges of the glass slide with the knife. but also at the same time you want to stay, let's say 3 to 5 millimeters away from any structures that are that you're trying to fabricate. And that's because you want to have enough PDMS around your structures to make sure that it can bond properly to the substrate that you use afterwards to make the actual device. So here I'm going to just put it against the light to check where I need to cut because the contrast can be a little bit poor. So I'm going to make 2 little marks with the knife, a safe distance away from the structures that I'm trying to cut. And at this point you just have to trust the marks if you can't see it, and then you go in with the knife, try to go in at perpendicular to the surface, and you can feel free to get down to the bottom of the glass. So try to feel the resistance of the glass, try to feel that you have reached the hard surface, and then you just slowly but firmly drag it to make the cut. And the PDMS, it won't cut very fast, so you just slowly drag it, and all the time you have to feel that you are in contact with the glass. So don't worry about scratching the glass, because you will not scratch it with this steel blade. And you keep going with the cut until about here, okay? And now we're gonna do the same thing on all 4 corners, and in particular it's very important that you intersect the cuts in the corners, because otherwise you will not be able to peel it off. So I'm gonna go in and cut a little bit more through here, relatively close to the edge. And that's the 3rd cut. It's not particularly important that the cuts are straight, as long as they contain the structure that you fabricated. And there we go. So that's the cut now done. So I'm going to put the blade away. And now I'm ready to peel it off. So I will stick my tweezers in the gap in here, and I will peel it off like so. And if it's all cut correctly, it should come off quite easily. And this is now the piece of PDMS with the channel structures. So we're going to leave the channel structures facing up, and we're going to put it over here. Now for the punching itself, we have to line up the punch needle with the inlet that we want to punch. And this can be a little bit difficult if you're using a thin layer of SU8. So in this case, you've got 15 micrometers, and the contrast is not very strong. So if you got a good eye and you already know what you're looking for, you can already line up the piece of PDMS, and specifically the inlets that you're trying to punch with the punch itself. But if you want to make your life a little bit easier, you can actually use a small piece of tape, specifically this tape. This is 3M Magic tape, that's the product name. And this tape is slightly opaque, so it's got this white translucent color, and if you put it on top, it actually highlights the features of the channels. And now I can see a lot better where I need to punch. So this would be one of the inlets that I'm interested in, and I'm not sure how much that is visible on the camera, but you will be able to see it a little bit better with the tape. So we will go ahead with the punching now. So now I'm going to take the piece of PDMS. I'm just going to fold this piece of tape so it's a little bit easier to handle. And now I'm going to put it on the cutting mat, and lowering the lever just gently by a couple centimeters until I'm a few millimeters away from the surface. I just check that I'm in the right place. And once I've lined up the puncher with the hole, I don't need to keep hold of the PDMS chip anymore. But now we come to the critical part about actually making the punch and punching the hole. So because this instrument is quite delicate, and specifically the attachment, so the cutting needle is very delicate. So you have to know at what point you passed through the PDMS and you got into the brown cutting mat, but you definitely want to avoid hitting the bottom aluminum plate with the punching needle. And so the punching tube must not touch possibly the aluminum block on the bottom. And to see whether that is the case, you want to keep an eye actively during the punch, or you want to keep an eye on where the punch is inside the PDMS. So the best way to do that is to put yourself right in front of the PDMS chip, and you look at the cross section of the chip, and you're looking at when the punching tube goes into the PDMS, and you follow the profile of the punching tube until it reaches the brown cutting mat. And once you reach the brown cutting mat, you keep going for about 1 millimeter or so, and then you have to stop to avoid hitting the aluminum on the bottom. So I'm gonna go in now. This might not be very visible on the camera, but you just want to go very slowly. And here we go, we're going into the PDMS, and now we're sort of halfway through, and a little bit more. Now we reach the brown bit. I'm going to keep going for about another millimeter, very gently, without forcing it. And then I have to be really careful at this point not to pull the lever accidentally, particularly if you want to pull yourself up. Make sure you don't pull on the lever as well. And at this point you want to hold with your fingers the PDMS chip near where you punch the hole, and you slowly retract the punch itself. And as you retract it, it will come off relatively easily, and now you have to check where the cutout of the PDMS is. Most commonly, this piece, there will be a piece of PDMS sticking out on the back side of the chip. So this is specifically the one that I'm looking for. So with a pair of tweezers, you can gently pick it up and pull it slowly, and this will give you the cutout of PDMS that you're looking for. So make sure that every time that you punch a hole, you are able to see that you've got your PDMS plug removed from the hole. 90% of the time this will come out on the other side of the PDMS chip, but sometimes it may get stuck inside the hole itself, particularly if you haven't cut the hole all the way through, or sometimes as well it can remain stuck inside the punching tube. If that happens, there is a different accessory here, which is looks like a long needle that is like this. This normally would be mounted directly within the instrument through here. However, this got damaged a few weeks ago during the training process, and so we're now unable to slide it all the way through. But this is not a big deal. We can keep still using the punches. And if it happens that the punch is clogged, you can just undo this gently, remove it, and then using this accessory here, you just slide the needle inside the punch, and then it will come out to the other end, and you can push out any piece of PDMS that has remained stuck inside. And that's it. So using the tape, it actually, from my experience, tends to generate this problem a little bit more often. So still, most of the time, you will have the PDMS cutout coming out on the other end of the PDMS chip. But if you're using the tape, a little bit more often, you might get the piece of PDMS stuck inside the cutting tube. So make sure that you remove it with that. And so after that, you go on and punch all the different holes that you need to punch in your PDMS chip. And once you've done that, you are ready for the bonding step.